Viewers, you are welcome to my YouTube video today. I'll be solving a problem that will take you through probability, okay? And in this problem, it has three segments. Each of the segments will be using the definition of probability, which is the ratio of the possible outcomes to the total outcomes. And the problem involves a pair of fair dice. A fair dice has 6 faces, with each of the faces having dots representing numbers, right? So if I have 1 dot, it stands for 1, 2 dots for 2, 3 dots for 3, 4 dots for 4, 5 dots for 5, and then 6 dots for 6. So the minimum dot you can have on a face is 1, and the maximum you can have is 6. It's said to be fair because the likelihood of any of the 6 faces showing up when you toss one die or a pair of die is equal, meaning it is equiprobable. So none of the faces have a higher chances of showing up compared to the other, because if that happens, we say the dice is biased. So this dice is fair, okay? And as I've mentioned earlier, there are 6 numbers, 1 to 6 on each of the 6 faces. So that gives the outcome of a dice. And this problem will be using perfect squares. What are perfect squares? They are numbers whose square root is equal to a whole number. For instance, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay? This problem will also show you how to sum up 2 numbers to get a perfect cube. Perfect cubes are numbers whose cube root is a whole number. So the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. I'll read out the question. If 2 fair dice with faces numbered 1, 2, 3, 4, 5, and 6 are tossed together, what is the probability that the total score will be 1, a prime number, 2, a perfect square, 3, a perfect cube? To solve this problem, I will pull out my table, and the first row will contain numbers equivalent to the dots on each of the 6 faces of a fair die. So the first die, I'll have 1 signifying 1 dot, 2 for 2 dots, 3 for 3 dots, 4 for 4 dots, 5 for 5 dots, and then 6 for 6 dots. And then the second dice, we have the same numbers, 1, 2, 3, 4, 5, and 6. So if I toss 2 fair dice, I'll write out the possibilities in each and every one of these cells, okay? So if I toss it, the possibilities are 1. I can have a 1 and a 1 showing up. I can have a 1 and a 2 showing up. I can have a 1 and a 3 showing up. I can have a 1 and a 4 showing up. I can have a 1 and a 5 showing up. And I can have a 1 and a 6 showing up. In the other way around, if I toss it, it's possible to have a 2 and a 1 showing up, a 2 and a 2 showing up here, a 2 and a 3 showing up, a 2 and a 4 showing up, a 2 and a 5 can also show up, and then I can have a 2 and a 6 showing up when I toss the 2 fair dice. It's also possible to have a 3 and a 1 showing up, a 3 and a 2 can show up, a 3 and a 3 can show up, a 3 and a 4 can show up, a 3 and a 5 can show up, a 3 and a 6 is also possible. It's possible to have a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, a 4 and a 5, a 4 and a 6. It's also possible to have a 5 and a 1, a 5 and a 2, a 5 and a 3, a 5 and a 4, a 5 and a 5, and then a 5 and a 6. Then you can have a 6 and a 1 showing up when you toss the 2 fair dice. A 6 and a 2 can show up. A 6 and a 3 can show up, a 6 and a 4 can show up, a 6 and a 5 can show up, and then a 6 and a 6 can show up. Now, to answer the first part of the question, I'm going to be summing up each and every one of the content of the cells. But I don't need to do all. I just need to figure out the ones that will suit my taste. Okay. So the probability that the total score will be a prime number. So I'll be on the lookout for a prime number. But before I do that, what is a prime number? A prime number is a number that can be divisible by itself and one alone without a remainder. Okay, so I will say the first question, the probability of a prime number equals, so I'll be summing up the two pairs to have a prime number. So 1 plus 1 is 2. 2 is a prime number, so I'll underline it with a blue line. 1 plus 2 is 3. 3 is a prime number. 1 plus 4 is 5. 5 is a prime number. Okay, 1 plus 6 is 7. 7 is a prime number. So I'll underline each and every one of the pairs with a blue line. I'll move to the next row. 2 plus 1 is 3. 3 is a prime number. 2 plus 3 is 5. 5 is a prime number. 2 plus 5 is 7. 7 is a prime number. I'll move to the next row. 3 plus 2 is a prime number, 5. 3 plus 4 is a prime number, 7. And that's all for this row. The next row, 4 plus 1 is a prime number, which is 5. 4 plus 3 is 7, a prime number. And then that's all. The next row, 5 plus 2 is 7, a prime number. I'll underline it. And then 5 plus 6 is 11, which is also a prime number. Then the last row, 6 plus 1 is 7. 7 is a prime number. And then 6 plus 5 is 11. So I'll count the total pairs that give the total pair that gave me a number that is a prime number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability that if I toss two fair dice, that's the probability that the total score will be a prime number is 15 divided by the total outcome. So the possible outcome is 15 and the total outcomes is 36. And then if I reduce this fraction to its simplest form, 15 divided by 3 is 5. 36 divided by 3 is 12. So my answer is 5 divided by 12. I'll move to the second part of the question. What is the probability that if I sum up the two numbers, it will be equal to a perfect square? First, what is a perfect square? A perfect square is a number whose square root is a whole number. Okay? So the only feasible perfect square that I can get by summing up the two numbers in a cell is 4, most likely 4 and 9. Okay? Because the maximum number I can have here is 6 plus 6, which is 12. So any other value any other possible value is less than 12. So I will target 4 and 9. So I'll look at this row. Okay, I have 4 here. 1 plus 3 is 4. Okay, before that, let me write out my acronym. I use P, capital P, to represent the probability and PS to represent perfect squares. Okay, so the first value is 1 plus 3 is 4. The next row, 2 plus 2 is 4. The next row, 3 plus 1 is 4. So all these numbers are perfect squares. That's why I'm underlining them with a blue line. And then if you move to the extreme end of this row, 3 plus 6 is 9. 9 is a perfect square. I move to the next row. 4 plus 5 is 9, a perfect square. 5 plus 4 is 9, a perfect square. And finally, 6 plus 3 is 9, a perfect square. So the total score that is equal to a perfect square from these total possible outcomes are 1, 2, 3, 4, 5, 6, 7. So if two fair dice are tossed together, the probability that the total score will be a perfect square is 7 divided by the total outcome. So the possible outcomes are 7 and the total outcomes 36. I can't reduce this fraction to any simpler form, so my final answer will be 7 divided by 36. I move to the last question. The probability that the total score will be a perfect cube. A perfect cube is a number whose cube root is equal to a whole number. And the only perfect cube I can get from this data is 8. The cube root of 8 is 2. The next perfect cube is 27. And I've mentioned earlier, 6 plus 6 is 12. I can't have any number more than 12. So I'll only target 8. Okay? So from the first row here, I can't get any value that sums up to 8. But before then, I'll write my third question. The probability of PC means perfect cube. So I'll now move to my data. 2 plus 6 is 8. So that's my first perfect cube. The next perfect cube is 3 plus 5 is 8. The next one is 4 plus 4, 8. And then 5 plus 3 is 8. And 6 plus 2 is 8. So the total score that is equal to 8, how many are they? 1, 2, 3, 4, 5. So the possible outcome of having a perfect cube is 5. And the total outcome is 36. So the probability that if I toss two fair dice together, that I will have a total score that is a perfect cube is 5 divided by 36. I do hope you are clear with the solution. Kindly drop your comment at the comment section. And if you have a question, feel free to send it to me either through the comment section or through my email, and I'll respond to your problems. I'll answer your problems, and if possible, I'll upload it on my YouTube channel too, okay, for you to see. Thank you once again for watching my YouTube video today. If you have forgotten the name of the channel is Victor in STEM, and if you've not subscribed, kindly do so. Hit the subscribe button and it will sincerely be appreciated. Thank you.